Thought I'd shoot a real quick video of how I set up a early Ford distributor on a Sun machine and how I set them up after I rebuilt them. This is one that I just got through rebuilding. This is a typical 37-41, technically 37-40 Ford distributor, 68 weight, 68 series shaft. This is my Sun Model 500 distributor tester, similar to a 504. This one's been restored and calibrated and all that good stuff. You're gonna have to bear with me. I'm not used to working one-handed. Let me go and line this up real quick. I don't personally care for the Sun quick clamps that come with the flathead adapter, so I've just got standard hex bolts run through the adapter, and I just use a standard 5/16 24 hex nut and just tighten one down just to kind of hold the distributor steady. Now, just to try to give a quick brief overview of what's going on here. This is a V8 distributor, and a V8 engine fires on 45 degrees. So if you drew a circle such as this on the Sun machine, it's going to come up to 360 degrees. As you can see, the circle ends at 360 degrees. If you were to divide that circle by 8-cylinder engine, divide 360 by 8, you come up with the 45 I just mentioned. Now, our objective on this distributor is to set, in an ideal world, which is not exactly an ideal world, but is to set each set of points at 22.5 degrees is the ideal purpose. Now, our left-hand set of points is more imperative because that's the set that opens and fires the plugs. We really want to put our emphasis on being sure this one's at 22.5, more so than the right side. But again, in an ideal world, they would both be at 22.5. Now, as the ignition system works, when the points are closed, it's charging up the coal, and when they open, it lets the coal fire. So if you add 22.5 and 22.5 together, you come up with 45, which in theory means that the points would never open, which makes zero sense at all. But these early Ford dual point distributors have 10 degrees of overlap. So there's 10 degrees of rotation that both sets of points are closed at the same time. So if you subtract that 10 from the 45, you come up with 35 degrees. That's our target number for our dwell setting. That's what we're shooting for. I usually set them at 34 because let me grab a screwdriver so I can point out everything I'm talking about. As this rubbing block that I'm pointing at wears, the dwell increases. Inevitably, as these points break in, a little bit of the slag on the machining end of these points is going to wear off and the dwell is going to increase. So if I set them at 34, I'm pretty confident that within a couple hundred miles they're going to be at 35. As a quick test I did on one of my cars, a 44 to be exact, I wanted to see, and as a side note, the car has a rebuilt Skip Haney coil that's fresh. I wanted to see at what dwell number would the car start to miss at. You know, pick up a ignition miss that I could fill with the seat of my pants. So I kept pulling the distributor on and off. And what I noticed is that at about 31 to 31.5 degrees of dwell, I picked up a miss, and the same at about 38.5 to 39 degrees of dwell, I picked up a miss, both at higher RPMs. So that tells me that the median point of those two numbers is around 35. So 35 is really a good target number. Plus, that's what Ford specified. Now, Sun, Ford, pretty much any instructions you read is going to recommend you install the coil. My theory is that there's a bit of a gap between this, I'm using my screwdriver again, this housing and the breaker plate. Not much of a gap, couple thousandths, but you know, we're talking thousandths of an inch of point gap here. You move this breaker plate down 2 thousandths, you're opening your gap up roughly 2 thousandths. Rather than using a coil, I just use a modern remote coil adapter plate. It kind of achieves the same purpose as what I was just talking about. Well, before I do that, I'm going to take this tag off. We tag all our distributors that get sent in so that we can be sure that the person gets back the same distributor they sent in. Let me take that off. I'm going to put my coil plate on here. Rather than using actual screws, I just use these little thumb screw things. They're just, since I'm back here doing these all the time, it makes it easier. As a side note, this high tension wound spring that's on the bottom of these coil adapter plates or ignition coil, you can kind of see I'm pointing out, it's a copper spring. You want to be sure that's never touching the housing or the snap ring. Now the picture's kind of blurry. You don't want that to short out. If it does, you're not going to get any fire at all. Let me go ahead and calibrate my dwell meter on the sun machine real quick. Just do that by connecting these positive and negative lead. I just used this earlier tonight, so it's already calibrated. Put on the 8-cylinder selection. Hook this up. We're going to first set the left-hand driver's side set of points at 22.5 degrees, and then we're going to set this side until we get to 34 degrees. That's just how I've done it. That may or may not be what everybody else does, but that's what I do. To be able to do that, we need to put something between the two contacts of this set of points. I just usually use a piece of cardboard or whatever I've got laying around. This is just a piece of cardboard off a box. I'm going to have to set the phone down. I'm not used to working one-handed. And then I'm going to just go ahead and block off that set of points. Hold on just 1 second. Alright, so I've just got a piece of cardboard stuck between the two contacts. So what we're going to go ahead and do, and when I set these distributors up, I can usually eyeball them and get them pretty close. I really didn't do such for the sake of the video on this distributor, but I'm going to go ahead and you can see our points are making contact because the arrows are flashing. We're going to go ahead and run up to about 500 RPMs. You can see, now that's distributor RPMs. 500 distributor RPMs is going to equate to about 1,000, well not about, exactly 1,000 engine RPMs. Look at our dwell, really close, we're 21.5 degrees. I've left my screws loose, you know, in case I need to make adjustments. I've noticed a lot of times just tightening the screws will increase the dwell. So I tighten that screw, and let me tighten out one. We're pretty darn close as we sit. That's kind of strike of luck. Sometimes you get lucky. This one didn't require any adjustment. You just tighten the two screws and they're right where I need to be. 22.5 degrees. We're going to go ahead and turn this down. Unblock our right hand set of points. Now we're shooting for 34 degrees. Get up to about 500 RPMs again. A little low. We're right at 32 degrees. So I'm going to go ahead and this is the adjuster. It's highly recommended you do not have the machine on while you're adjusting, because if this screwdriver hits the rotor while it's spinning, it could cause personal injury, certainly break the rotor, and no telling what else. But I've done enough of these, I'm pretty confident, although I am working one-handed. So you can see as I'm moving the adjuster, I'm moving it back and forth just to show you. And I want you to look, this is all I'm moving. It doesn't take much. So I'm going to put that at about 33 degrees. Because usually when I tighten these screws up, it closes the gap. Just tighten both our screws up. I use these Allen head screws, which makes it easier. Go up here. We're pretty much where we need to be. 34 degrees. This one was easy. Usually they're not this easy. I'm going to go ahead and turn this down to, you know, lower RPMs, about 250 degrees. Excuse me, 250 RPMs. Our dwell is a little higher. Mostly that's because I'm messing with my timing adjuster here. You want to be sure this timing adjuster is tight when you're setting up the distributor. It was. I just loosened it. You could watch as I was loosening it. You could see the dwell moving a second ago. You want to be sure that's tight as you set up the distributor. Now, I've got 2 marks under my distributor with a silver sharpie, here and here. I've set up a distributor on my Taylor Wilson fixture, put on the sun machine, and put a mark where the timing is supposed to be. Now, temperature affects these machines. This is not a very accurate way, but usually gets me close. So we're down here, 250 distributor RPMs, right around where it would be if the car was idling. You can see our timing is off by about 4 degrees. I'm going to go ahead and advance it slightly. I have to set the phone, I'm going to have to move the phone to do this. So I've moved the timing. I've got it on the silver mark, which means it's going to be close. It might not be exact. We'll find out here in just a few minutes. I'm going to tighten it back up. So now what we're going to do, this is a 68 series distributor. It should advance 8 to 9 degrees. So as I crank up the RPMs, you should see it come right around where my screwdriver is sitting right now. So first one to do is we want to see at what RPMs it starts to advance at. So we'll check that first. Right about there it started to move. About 750, 1500 engine RPMs. Now we're going to go ahead and advance it. Be sure it advances to where it's supposed to. And see at what RPM it does that. So at about 3,200 RPMs, this distributor is fully advanced. I have the vacuum brake installed and I have a 1/4 turn of tension on it. So we have 2 more tests we want to do here. We want to see at what RPMs the points start to float. That to me is more imperative than anything. The phone kind of messes with the arrows. It's not picking it up very well, but there's 8 arrows flashing. When the points start to float, you'll see extra arrows start shining on here. I'll point it out when it happens. What we want to do is we want to see what distributor RPM that happens at. Always remember you multiply this number times 2 and that'll tell you your engine RPMs. The last thing we want to check is after we've checked that, we're going to bring it back down to idle, 250 RPMs. And we want to be sure that this arrow comes back static to 0. If it doesn't, your weights are sticking. Very common problem. You want to be sure it's not happening. So let's go ahead and see at what RPMs the points start to float. Alright, so briefly what I did is I ran it up. You can see multiple arrows flashing, and I turned the RPMs down until those extra arrows kind of disappeared. And I shined the camera up here. You can see it's about 3,200 RPMs, which would be 6,400 engine RPMs. Nobody's ever in their wildest dreams going to turn a flathead engine 6,400 RPMs. So last thing I pointed out, we brought it back down to 250 RPMs, which is roughly about where a car would be at extremely low idle. And we noticed our arrow came back to the 0 marker, which is what we want. So we're just going to recheck our dwell. Now we've run this thing pretty heavy at pretty high RPMs. We're going to get right back up here about 500 RPMs, 400 around that range. About 500. Check our dwell. Almost 35 degrees. So you can see we started out at 34. Just run at one heavy time, extreme RPMs, kind of broke the points in just enough that we actually gained about 3/4 of a degree of dwell. So that's going to set us right where we want to be. So I'm pretty confident now. Our timing's probably going to be close. We're going to check that real quick, but we're done with the sun machine. Always want to double check, which I know I've done it. The screws are tight, you know, when you're done. We'll go ahead and take it off of the sun machine real quick. I'm going to leave this coil adapter plate on here because our next step is we're going to take this distributor and we're going to put it over here on this K.R. Wilson fixture. I'm going to line up my these things. The tang, is most anybody watching this video will know, is offset on these distributors, so you kind of need to line it all up. I've had this K.R. Wilson fixture for probably 10 years, and I own 5 of them, but I always, since I've been messing with these things, I've always used the same fixture. Go ahead and hook our wire up to the adapter plate. So you can recheck your dwell. You see the light goes off and the light comes on right up there. There's a little, let's get a screwdriver so I can point out. You got the letter F right here, and there's a line right here. So we could line this 0 mark up with that line, spin it just until this light goes off. Spin it back. I wasn't paying attention. Right there. Now if we zoom in here, you can see that's right at 35 degrees of dwell. So in short, you can use one of these fixtures. You can see just tapping it, change it. There we go. In short, using one of these fixtures, you can actually set your dwell. You can do everything you can do on this machine over here, on this fixture, with the exception of checking for point float or how your advance weights are working. So if you polish your shaft and you do everything properly, really with one of these fixtures, that's all you need. So what we're going to do is we're going to go ahead, and you'll see this pin right here. There's a hole in this ring, and when this pin drops in that hole and the light goes off, you want that light to go off as soon as the pin drops in the hole. And that's right when your timing is right where you want it to be. This thing's kind of, they can be kind of tough to spin sometimes. So we're going to set our pin right here. Excuse the terrible video. There's your hole. Timing is just a little bit off. See, the light went off, watch it, before the pin drops in. Now it's probably not off with about 1 degree, but I'm gonna go ahead and try to fix that real quick. So I'm gonna have to set the phone down while I adjust this. So we're going to spin it back, and we're going to come back, flip our pin around, see your hole right there. I'll show you again. When that pin drops, the light needs to go off right at that exact moment, right there. So now our timing is set. Now, one thing I want to note, some distributor rebuilders think that you can just set this. This is a great example on this distributor. This usually doesn't happen. Some people think you can set these indicator lines right at the middle and that's where the timing needs to be. As you can see on this distributor, we've got this thing adjusted up, not all the way, but we're one mark from the end. And the timing is set exactly where it's supposed to be. So using the theory that if this thing is in the middle, the timing is set properly is incorrect. The timing is set proper on this distributor, and as you can see, this slider or adjuster is actually further up than typical. That can be relevant to a number of things, the shaft, the points, whatever. So this distributor is good to go. We'll check it again just to show you as soon as it drops in there, right there. And again, you can check the dwell pretty easily with these things. I love these K.R. Wilson fixtures. You see this, you'll see this this F mark on this line right here. So we're going to just spin it. So what I do is I grab the degree wheel and the line them up, spin it just till the line lights up, or excuse me, the light. I'll let go of the degree wheel. Now I'm going to spin it, just the actual distributor itself. The light just went off. I probably didn't show you that. I'm going to start over. Right there, the light went off. 35 degrees of dwell. That's all there is to it, guys. It's pretty simple. But the imperative thing that a lot of people miss is you have to set the timing. If I would have set this distributor timing slider or adjuster in the middle, like a lot of people assume is correct, this distributor would have been off 4 degrees of timing. 4 degrees off. If I put this distributor in the middle, very, very, very likely could have created an overheating condition. That's all there is to it. I'm sorry for the absolute terrible video that I've posted here. It's hard to work one-handed, and I've never posted a video before, so maybe next time I'll have some help.